Myself, Shubham Sharma. I am from Dr. D.Y. Patil School of Engineering, and thanks for giving me such an opportunity to present my paper here. Um, Topic of my research paper is AI-based smart glass for a blind people. This is guided by Dr. Yasan Inamdar sir. So, these are the content which I will discuss in this paper. So, aim of our project is to our research paper is to design a smart spectacle which will detect an object from a known class such as a people, car, or faces, etc. in an image. So basically, what is the need of this topic is? So as we know, the number of visually impaired people is growing over the last few years. According to the report of the World Health Organization, about 253 million people live with a visual impairment. Among them, 36 million people are blind and 217 million have moderate to severe vision impairment. The major portion of visually impaired people is age 50 or older and live in a developing countries. Every day, these visually impaired people face problems in understanding and interacting with surroundings, and particularly those with they are unfamiliar. So, so in this project, we are going to design a smart glass to solve this problem. So in this project, we are going to design a smart glass. So this will help to the blind people to do their daily work. So for this research paper, we have referred 5 to 6 papers. So the first one is the title of first paper is Smart Glass System using a deep learning for a blind and visually impaired people. This was published in 2021. Basically, this paper describes a smart glass system that includes object detection, a salient object extraction, and text recognition model using the computer vision and a deep learning for BVI people. Next one is a smart glass for blind people. This was published in 2021. Matching between the two images is done using a align image from rectification by finding the position of two points in a two images. Calculating that disparity using the values of x because of two cameras, they are the same position. The third one is a low cost ultrasonic sensor, a low cost ultrasonic smart glass. Basically, this used to just detect the object. This was published in 2018. This smart glass implemented for a blind person who are unable to see any object, but this person to avoid the accident. Smart glass, fourth one is smart glasses for the visually impaired people. This was published in 2017. This paper presents a new concept of smart glasses designed for visually impaired people using a low-cost single-board computer Raspberry Pi and its camera. For the demonstration purpose, the glasses are designed to perform the text recognition. First, so fifth one is a smart glass for blind people. This was established in 2019. This can be improved in the future for blind people and people who have visually difficulties by adding a new technique. For instance, direction and wearing message to prevent the expect accident. These are the few papers also we have referred for our project. Last one is a visual assistance for blind using image processing. This process is a wearable model for blind people, which is capable for identifying the object using image processing techniques and also the distance between the object identified using the ultrasonic sensor. In this Raspberry Pi module is also used for processing and algorithm. Then OpenSea and Python is also they have used. So in our project, what we will add new is we will trace the live location of the visually impaired people. Suppose in emergency, if that person want any need, so in emergency he can call to the caretaker or family member to help him. So we have defined our complete problem in one sentence. So we will implement an AI-based smart glass which will help to visually blind people. So our objective of this paper is to design an AI-based smart glass so that the life of that blind people can become easy, to develop a system which can detect a living and non-living object around the surrounding. Using this smart glass, we will improve the efficiency of that blind people and its independence of on another people. So this one is now we will discuss the methodology, how this complete project will work. So in this project, we will use Raspberry Pi, camera module, then ultrasonic sensor. Using this, we will design one component. So how this project will work? First, this will detect the distance of the object. After detecting that distance, that will calculate that distance and that distance and tell that distance to the that blind people. So how this object is far. After calculating that distance, this object will read that image so that blind people can understand what is that object. And if in emergency it need any that blind people need any help, so after pressing the emergency button, he can call to this caretaker or his family member to help him. So in methodology, in this project, we present a unique smart glass for visually impaired people to overcome the traveling difficulties. It can detect the obstacle and measure the distance perfectly using the ultrasonic sensor and microprocessor using Raspberry Pi. After receiving that information from the environment, it passes to the blind person through a headphone. Ultrasonic sensor will measure the distance between the two objects and person will inform to the user. When an obstacle comes near to the blind people within the range of 5 meters, the sensor measures the obstacle and distance sent via Raspberry Pi to the user. The SD card module has the ability to communicate with the microprocessor. These voices are recorded in the SD card module to instruct the visually impaired people, which is played through a headphone according to the trained data. Camera module is used to detect and read the object that will inform to the microprocessor. So next one is a simple block diagram. What our product will contain Raspberry Pi power supply, ultrasonic sensor, and the camera module. So these are the sequence system requirements. We need Raspberry Pi with 8 GB, and then speed with 2.5 GB gigahertz. Then we will use coding language Python to code this. This is a system architecture. So this is a 10 data set. This is a user. One is upload image and text to speech conversation. So train data set contains our train data, which we will save in the system. For blind people, we will train our data for 15 to 20 important things. So these basic things which will useful for that blind people. So how this will work? The user contains camera module. After capturing a image, this image will upload to the database. That image will be scanned in database. If that data is present, so after converting text to speech conversion, that object user will understand what is that object is, and the blind people will understand what is the object in front of him. So next one is the system explanation of system architecture. We have proposed the system for which people are blind. They are using this application. In this project, we are using image processing for a project to detect the object. We are giving input image and removing unwanted data besides, and then feature extracted and detected the feature of image and then classify with using CNN and ML algorithm, and that object will be detected. So these are the hardware requirements. We will use Raspberry Pi 3, ultrasonic sensor, camera module, headphone, batteries, and Raspberry Pi IDE. So Raspberry Pi, you may know the basics of Raspberry Pi. It is basically a card-sized computer. It needs to be connected with a keyboard, mouse, display, and power supply, SD card, and install operating system. Raspberry Pi is a low-cost embedded system that can do a lot of significant tasks. It can be run as a no-frill PC, a packetable coding computer, a hub for homemade electronic components. It is also a great machine to attract children to learn more about how computer work and motivate them to improve their programming skills. Next one is the webcam. This is used to capture an image, to read an image. In this project, webcam will be used in like an eye for a person who wear a smart glass. Next one is the battery. This is for a basic performance for a product. Headphone. This will use to provide a final output to the blind people. The headphone will use to help user to listen the text has been converted into audio after capturing that image. So, and this is the basic circuit diagram, Raspberry Pi and camera module. So advantage of our proposed system is our proposed framework can also be easily applied in a problem of image instance retrieval. To evaluate this proposed system, we conduct a extensive experiment under the multiple settings and compare with many representative studies. And our disadvantage required a good quality of image, cannot detect features from low quality image, and we cannot also detect image from a low quality, low voice. So these are the few our disadvantages. And our conclusion is we have proposed a framework for common object discovery and localization in a wide image. Like most device method, we are based on the assumption that there is only one object contained in each positive image. Inspired by mean cut max flow algorithm, we then present a constant subclass meaning algorithm to optimize the two models. We can classify and detect the object by using a neural network correctly. And these are the some references which we have used for this paper. Okay, so thank you, ma'am. This is from my side. Hello. Hello. Hello, Snehal ma'am.
Hello.
Please unshare your screen.
Hello. I'm audible.
Yes, please unshare your screen.
I have done, sir. Hello.
Yes, hello.
Yes, ma'am. I have done, ma'am.
Okay. Is there any question from the audience side? I think there is no such question. So thank you, sir, for your presentation. Thank you so much.
Thank you. Hello, ma'am.
Yes.
My group number was 23002.
2.
Okay, 1 minute. I am 1 minute, ma'am. I'm just checking what was my number. 23002. Shubham
2.
Sharma. Okay, ma'am.
Okay. Yeah. Yes. Yes. Yes.
I have done my presentation.
Yes. Yes.
Thank you, ma'am.
So, okay. So now I am going to call MICRT stamp 23003 is present here. No. Then MICRT stamp 23010.
Hello, ma'am.
23010.
Ma'am, mine is over.
Ma'am, I think now 23021 should go for the presentation.
23012. Yes. 23012 is present here.
आपली सेपरेट टीम झाली असती ना ट्रान्समिशन टेस्टिंग द्यायला पाहिजे नाही म्हटलं
Hello.
कोण नाही म्हटलं ते HR वाले काउंट वरती घेतलं म्हणलं.
Hello.
Yes, ma'am, you are audible.
Yes.
Hello.
23012 is present here.
Ma'am, 050 is present here. I think what is the sequence?
23012. I am going according to the PDF numbering.
Okay.
Yeah. Then 23013. 23013 is present here. Then 23015. Then 23023, 23021.
Yes, ma'am. 021 is present.
Okay, then you kindly present your paper and share your screen.
Excuse me, ma'am. Hello.
Yes, yes.
Uh, my paper is missed out. Miss, my presentation was scheduled at 2 o'clock. Shall I give after this?
Oh, what
Uh,
was your number?
041.
041. No, I am going according to the PDF numbering.
Yes, it was scheduled at 2 p.m.
No, now I am going according to the PDF numbering. So kindly wait for a bit.
Okay. Yes, ma'am.
Okay. Okay, ma'am, you continue.
Yes, thank you. Good morning, all my respected mentors and friends. I am Sayarya Katkar from Siagat College of Engineering, and on behalf of our team, I would like to present our paper AI-based virtual assistant for deaf and blind people. So, deaf and blind people are unable to communicate with us or with each other in general language or in English. Hence, they use languages like ASL or Braille to communicate. But we don't learn these languages, and hence it becomes a problem when we have to communicate with them or to talk to them. And our program comes into picture as we focus on bringing this gap down. We use natural language processing and Pi audio to detect the hand movements and that recognizes the voice and does the translation to either English or any other comfortable language accordingly. It even shows the text output, which can be read by other ASL users and interpreted with ease. We have used the following papers and books which propose the following results, like the one by Lalit Goyal and Vishal Goyal, which is based on text to sign language translation. It gives information about text to sign language conversion, but the disadvantage of this paper is that it doesn't contain brief information about all the software requirements. Then the next paper is by Andhra and five other teammates, which is based on American Sign Language Translator. It contains information about pre-processing, segmentation, and feature extraction, etc. But again, it doesn't have information about how to implement that job into a well-run project. Then the next one is by D.S. Shingate and his co-authors. It is based on sign language interpretation, and its advantage is that it contains detailed idea about sign language, but it doesn't have the idea about translation of the sign language into language that a mundane person will understand. Uh, we have used the following flow chart, and it goes like. First, we feed in the input, which in this case is a live video. It, it's then split into individual frames, and then comes pre-processing where it analyzes the data, like the size, proportion, background, color, the amount of blur, etc. Then comes segmentation to divide an image into individual segments, which then become easier to search for what is actually required. Further, we have feature extraction, where words from a sentence are individually recognized by using NLP and OpenCV. We recognize particular image descriptors or key points like the hand or the face movements, etc. Then comes classification to divide the analyzed inputs into particular sections and distinct classes where we compare it with a database as a reference. We are using the TensorFlow database, for example. Then once we recognize a sign and put through the labels, we give it as an output in the form of either text or in audio format as speech. We have used libraries like TensorFlow, then Python text to speech library, and the Pi audio. We use these libraries to train our model and increase its efficiency. Currently, we have trained our model into 5 of the following ASL actions and its audio files, like yes, hello, please, thank you, and goodbye. Then we have provided the input to the system that will include video input, image, or a voice note. This input language can be in English or sign two words at the same time, depending on the need. And we plan to improve it into an entire sentence too. And we will be able to collect up to 10 words at a time to form a text message and read it. The end result of the project is an interface that allows people with disabilities to especially easily communicate with people with disabilities. These are our simulations that we have done in our project. In this picture, you can see that the box is indicating the sign language that is done by the boy. And even we can hear a audio output when please is done, so that the person in front can hear without knowing what the ASL language actually is. So our project is an easy to use hands-free machine learning program where the communication gap between people with special disabilities and normal people like ourselves can be bridged without the need of a third person interpreter. And these programs currently on the market only help to convert sign language into text, that is to English, and it is generally done by using translators. But we solve these problems that even if a normal person wants to talk to a person with a disability without using a translator, he can do so by using our system. And we plan to develop our system into a viable app also, so that without even knowing the language, you can talk to and interpret what a person is doing and saying. So we have taken the reference of the following papers, books, and publications. Thank you.
Is there any question from the audience side? No, there is no such question. So thank you, ma'am.
Okay, thank you.